Hi everyone, welcome back. So in this video, we're going to talk about a concept called ArrayList. And let's first start this off by thinking about, well, what is different about this concept of an array list in Java versus arrays that we've seen kind of thus far. And what I would like you to think about is thinking about the operations that take place when we're operating on an array. Okay, we've seen some of these before, but we're going to look at it from a bit of a different angle. So if we think about arrays, right, we've got a couple operations or functions that we can support. So we want to think about this as, imagine this is you as the programmer, okay, and you're trying to use a library, okay, so you got some sort of library over here, okay. And let's have this a library has a bunch of functions and operations that we can support related to arrays. Okay, so I'm actually going to call this an array list library. Now, a programmer might want to do a few different things related to using this library. Okay, maybe the programmer wants to create an array. Okay, maybe the programmer wants to instead of create, maybe wants to, the array's already created and wants to basically add something to the end of the array. Okay, whole lot of operations that we could imagine. Remove something from the array. Okay, get something from the array, right? Maybe get the size or get a particular value. So what we're thinking is we're kind of looking at what's the interface, or what is the way or the communication that goes between the programmer using the library. Okay, so you have like these two different elements. You have the library itself, right, and as well as you've got the programmer. The programmer is basically using pre-built functionality that's already exists that we just want to leverage to be able to do something useful. Okay, so another way to think about this is like, I'm going to do something called pseudocode here, okay? And so this is pseudocode. If you haven't heard the term before, literally translates to fake code, right? Pseudo meaning fake. Fake code, it's not in any real language, but just kind of a construct to be able to think about how we're, like, the logic and that we want to implement. And then it's kind of language independent. You can imagine taking pseudocode and then transcribing it into different programming languages depending on what you're trying to do. So let's think about this, right? Let's imagine, if we've got our pseudocode over here, okay, so we got our pseudocode. Maybe we have something where we want to, say, create an array, okay, and then maybe we want to add to that array, right, maybe digit 1, right, integer 1, so we have an array that exists, right? So maybe we're continuing to add or append things onto an array, right? We have these different, these different operations we can support, okay? I'll do a different number, we'll do 5, okay? And, we could have some, so those are kind of the obvious, like kind of appending things, right? We could have like where we're able to have some operations that give us the size of the array, right? So that it's size 3, right? So we can have like something that gets the size, okay? We could have something that gets a particular location in the array. So get like location 0 would be this, right? So there's all these different operations that we want to support. And this is going to bring us to the concept called ArrayLists in Java, where we're effectively going to be able to use a lot of pre-built functionality to make it a lot easier to be able to manage arrays. And the arrays could be of all different data types. They could be integers, right? They could also be different types of arrays of objects that we'll look at as well. Okay, we won't be able to do this all in one video. We'll split this up a little bit. Now, before I do this in Java, we actually look at real ArrayList. I'm going to shift for a moment where we look at how to do something kind of similar in C. And the reason I say kind of similar is C is not object-oriented. There are limitations of what we can do with the language, but I want to kind of ground what we're doing into something that we have seen before. That's somewhat similar. So that this way we can kind of connect what you're going to be seeing in something new to something that should look quite familiar to you. And then also be able to kind of bounce back and forth between the languages a little bit, between C and Java, to kind of give you that perspective of the differences between the different languages. Okay, so let's switch and let's look at a small example in C and see how this compares. Okay, so here's our example in C, and let's look down at the main first. In main, and I happen to call this this data type that we defined, it's a structure. I ended up calling it ArrayList just to be consistent with what we're going to see in Java. But this is something that is a custom defined name that a name I gave by defining a data type, building a structure. So let's look at this structure here that I called ArrayList. And what that is a structure that contains just two elements, two data members, right? One is an integer pointer that is our array, okay? And the other is the size. So effectively, we're encapsulating these two elements together. We're encapsulating the array and the size. We're containing them into one data type to make it easier to kind of manage those properties together and giving it one name. And I happen to give the name ArrayList just to be consistent with what we're going to see in Java, okay? Now, this might look familiar to you because if you look back to what we were covering in C, we talked about something in C related to an abstract data type, okay? Abstract data type. And that's effectively what this is we're looking at an abstract data type, and the one that we saw previously is we called this abstract data type a vector, and it had all sorts of operations that we could support. Right? When I say operations, I'm really referring to functions that operate on that data, the data type that we've defined. Okay, so vector, for example, we define that as a way that we can have all these different operations that we're talking about, like a small subset of that now. These operations such as add, remove, insert, all these different types of operations that we might want to regularly do on an array. Okay, so enough of that. So what we got here is we got something, we're initializing our array list, okay? I'm setting the pointer to null. I'm setting the size to 0. Now, we could have broken this up in a function too to initialize it, but we just happen to do that here, okay? And then I'm adding a bunch of things to the array, okay? I'm just basically continuing to append. So where this should mostly look familiar to you is that we've looked at these types of operations, these types of functions in C. Remember, right now we're looking at C. And we looked at this and we did it in the context of an append operation, okay? Now, let's look at this. I called it add partially to be consistent with what we're going to see in Java. We come up here, we look at this function, right? It takes in two input parameters, an array list and an integer. The integer is going to be what we're going to be appending to the end, okay? The append to the end of the array. We're using realloc on line 11 here. We're using realloc to grow the size of heap memory, okay? And one thing I want to point out here is C is giving you a perspective of what's happening at the lower level, kind of hardware level, like what's going on with memory, right? It gives you a much better perspective of how we're growing heap memory and everything. You're seeing those functions like realloc, okay? That's one of the reasons that C has its place and is very widely used for certain types of problems, is it allows this like greater level of control where Java hides a lot of that from you. Now, sometimes you want it hidden, sometimes you don't. It depends on what you're trying to do, okay? But what I'm kind of trying to get at is Java is doing this kind of stuff. It's just hiding it from you, okay? So here, how we're growing heap memory, right, when we're appending to the array, okay? We're then setting appending the new value. We're increasing the size, and then we're returning the array list data type, okay? If I run this, I'm going to get value 1, 2, 3, 4. I'm basically dumping out everything that's in the array or the array list, okay? And what I'm kind of getting at is we're starting to look about how you could build a library Okay, how you can build a library of functionality that of all these different types of operations that support operating on arrays. So we could expand this. We've looked at some of these before. We in the context of looking at like the vector abstract data type and so forth. We have this add function, but we could build a remove, we can build an insert, we can build a get size or something, right? There's all sorts of ones that we could build, all sorts of operations that we can do, the functions that operate on this data, and we can encapsulate all of those into a library, make it very easy to kind of operate on that data, okay? But anyway, enough of that, right? Let's contrast this. Let's shift back over into the Java world. Let's look at how we would basically take something like this and do something useful in Java. And you see that Java is a lot easier than C for certain types of, in terms of handling logic like this. Okay, and I'm going to start off. I'm going to just build something very, very simple. Okay. Let's look at the first part of this in particular of how we would declare an array list. Okay, how we would declare an array list. So I have this data type called ArrayList. Okay, I'm going to call it array, and I'm going to say new array list. And it's going to look like this. Okay, this is the line for creating an array list. Now notice, right now, it would fail to compile. And I get a nice little helpful hint here from the IDE telling me that I need to import java.util.ArrayList. Okay, effectively, I need the library, right? Like I mentioned before, right? We're using we're using code that has been written by others. This is part of a standard Java utility. That's a very common thing to use. But we need to include it. We need to basically have this import so that we can leverage that functionality written by others. Okay. Effectively, as we saw in a previous video, right, this is calling a constructor that exists in the library. Okay. The one thing that's very, we can see when we're using new, we're allocating space on the heap. Okay. And this here, okay, that I'm highlighting says integer. Okay, that's telling us that we're creating an array list. This is the ability to create an array list of all sorts of different types. They could be integers, they can be doubles, strings, or any sort of object that you've created. Right, so you can have the name of a class here, right? Like if you had an array of students, which we're going to actually see later on. These can be actually much more complicated or abstract data types for ones that you've kind of custom defined, right? But we'll stick with integers at first. All right. Now, for the array, if I say array dot, I get all these helpful dot completion suggestions for things I want to do, right? And we could see I can add something, right? Say I wanted to do like add 1 to the array, okay? I could go ahead and do that, right? I can use the add operations, okay? And if I want to print the array out, we could do that too. I can say array dot size, okay? And I get all these helpful, when I do the dot completion, I get all these helpful reminders of what should be in there. I'm just going to dump the array to the screen. We'll print them all on the same line. And if I want to get so the syntax is a little bit different in here, right? Usually we've seen things like this, okay? Where that's how you would get at the array. We do not do that with ArrayLists, okay? So previously, how we saw, before we were using ArrayList, we were generating arrays like this, okay? Where I put in the size of, so allocating it all at once, and I could, here, I'll just call it A. And then if I wanted to set something, this looks very similar to Java, right? I would be doing something like this. So this is the way that we've seen it kind of going both in C and Java so far. I mean, the syntax of allocating space looks a little bit different in Java, where we say new int in the size, but it's very similar. at least in very conceptually what we've seen in C, and then we're using the square bracket notation to designate which, what index in the array we're trying to get at, okay? When we're using ArrayList, we're using this object-oriented framework, and we're calling a constructor here, okay, in an ArrayList class, okay? And what I'm getting at is now all the operations, anytime we want to do something with the array, we're doing it with functions, okay? We're doing it with functions. And functions have these parentheses. They don't use square brackets, okay? So this is the old way, okay? It works, right? We've seen it. I intentionally left it like that as we were learning Java because it was the most similar to what we've been seeing in C, okay? However, we can't do that. Notice that's not going to compile here. Effectively, if we want to get an item out of an array list, we have to do everything through a function, and we're going to use a get function. Okay, that's going to say, hey, get me that item. Notice we're not using the square brackets. Okay, now let's test this. Kind of compile and run. All right, let's run this thing. Okay, and notice I didn't put spaces between, but we get 1, 2, 3. Okay, so this gives a sense of we're doing a few key things here. Let me point out a couple what we've done thus far, and then we can expand it a bit. For one, look at the syntax for how we're creating an array list. Okay, notice we're creating it. We're allocating space dynamically, right? We're allocating space on the heap. Okay, we can grow the space. We can reallocate space, right, to make it bigger. By adding it, and there's no limit to this. We can add as much items as we want to the array. Okay, we use add for appending to the end of the array. We're using size to get the size, and we're not using square brackets to get a particular element of the array. We're using .get to get access to it. Okay, now I can also override, like say I decided at some point I wanted to change an existing element in the array. So say instead of this being 1, 2, 3, I wanted to change this to be, I don't know, 7. Okay. Well, that's in location 1, right? We start counting at 0. So 0, 1, 2, right? Location 1, right? And I can change that value there to whatever I want. So like say 7. Okay, so notice we've got this like get and set operation, similar to what we saw in previous videos. Okay, here if we're going through the get, right, that is a read-only operation, right, while the set operation is a write operation. Okay, so this, and here I'll make it so that we have some space between the items. This should print 1, 7, 3, right, because we're overriding this thing in location 1 with 7. Okay, so let's run this. Okay, 1, 7, 3. Okay. Now, one kind of key thing about object-oriented programming to point out is notice that doing it this way, where I say array dot something, I don't need to pass in the data of the array. It's already accessible, right, for the fact that I'm saying array dot and then the operations on that data. So we're containing both the data that we want to operate on as well as the functions, whatever kind of logic we want to do on that data. Okay. There's a whole bunch, and I won't go through them all, but there's a whole bunch of things that exist in here, right? I can remove something, right? If I did this, I'm removing from location 1. Now it's going to print 1, 3. Right, this is kind of irrelevant, okay, because it's going to disappear. So I can remove something. Okay, 1, 3. Notice it updates the size automatically. Okay, so there's a whole bunch of different types of things for different logic that we can use. I could check if something is empty, right? Right, if I wanted to know if there's anything this is common, is to know if you have any data there at all. You know, so you can have it's a Boolean return, so you can check. That's very helpful. So there's a whole lot of different operations. The documentation is important because you can reference and you can look up all these different what these different functions do. But I've kind of showed the common ones now. So, okay, now what I would like to do is in a separate video take some of what we've seen here, and we'll expand our university application that we've been kind of building upon across multiple videos. We'll expand that to look at how we can use some of these concepts to implement some functionality in the context of a real problem. Okay. All right. So be safe and healthy, everyone. Please make sure that you are staying on top of everything. You know, I don't expect you to, like I've mentioned many times, I don't expect you to understand this stuff in one shot going through a video. Right? A matter of fact, even going through the video multiple times, it's not really going to stick until you kind of listen to the video and then try things out. Going to zyBooks, trying out, going through and working through some problems, you know, connecting it to the homework, connecting it to the labs, right? It takes practice. If you're not practicing it, it won't stick with you. You'll never remember it. Okay, so stay healthy, be well, and have a good day.